Okay, good morning everyone. I think you are able to see my screen. Okay. In last session, we have seen how to write big number program in different ways. So we covered almost 18 different ways for this. And if you want to go back and see where the programs are available, you can just go to this link. You can find all those programs. That means in the last session, we covered how to write a big number program in different ways. So all the ways are available. So you can go ahead and see here. Okay. Thank you. Now, in today's session, we will see how to write prime number program in different ways. Okay. So we can cover today almost 11 different ways. 11 different ways. Okay. Okay. So before we start, let's understand what is a prime number. Before we start, let's understand what is a prime number. So by this time, everyone knows what is the prime number. Number which is greater than 1 and has only one divider, which is itself, is called a prime number. So that means what? Okay, so if we see prime numbers, let's take 5. If you see, it is having factors 1 and 5. In between 1 and 5, you don't have any factors. Let's take the 11. Let's take the 13. Let's take the 17. These are all the different prime numbers. Okay, these numbers, if you observe, it will have factors 1 and itself. There will be no other factors. These kind of numbers are called prime numbers. Numbers other than 5 numbers, other than prime numbers, are called composite numbers. Number other than prime numbers are called composite numbers. So what are the examples of composite numbers? So 4, 6, 9, okay, 10, 12, all these are the composite numbers. Why? If you see 4, it can be divided by 2. If you see 6, it is having the factors 2, 3. It is having the factors 3. It is having the factors 2, 5. It is having the factors 2, 3, 4, 6. These are the different factors. Hence, these are called composite numbers. Okay, so let's see some of the important bits. Okay, so let's see important bits. The first one is minimum prime number is 2. Minimum prime number is 2. Then if I am saying minimum prime number 2, then obviously the next question is what is the maximum prime number? So anyone knows what is the maximum prime number? If you see Robo movie, okay, so there the scientist will ask the question, what is the maximum prime number? Then the Robo will tell the answer, and it will tell, okay, or it tells how many days it will take to calculate it. So it's like a years. So okay, same thing here also. So the maximum prime number is something like this, power of 2 power 74 209 or 207 281. This is the and minus 1. So this is the maximum prime number. That means 2 power 74 207 281. This much of big number. It's like, if you see how many digits are there in this, if anyone asks, 2 power 8 means what? sum 64. That means it is having 2 digits. So if you see how many digits are there in this, so the total number of digits are 22, 338, 618 digits are there in this. That much of big is the prime number, and this is found in the 2016. So every year they are finding some big prime numbers. If you see in 2015 there are a lot of prime numbers. Okay, the same way 2016 this is one of the prime number they found. Okay, people also called this as M74, okay, 207 and 281. So this is called M series. Okay, so whatever you have here, so you can just add after M. So people call it as M74, 207, 281. That is also a prime number. Okay, so next one is between 1 to 100, how many prime numbers are there? This bit you see in most of the competitive exams. Between 1 to 100 there are 25 prime numbers. Between 1 to 100 there are 25 prime numbers. That's it. So these are the some theory about the prime numbers. Now let's see how to write the prime number program, or how to write a program to check whether given number is prime number or not. Okay, write a C program to check given number is prime number or not. Okay, so I'm just starting the code. So let me take a number, then so obviously I required a flag variable. So initially I'm saying flag equal 0, CL or SCR. Okay, then printf enter number. So someone is going to enter the number, scanf. Okay, %d, comma, address of number. Just read the number. Once you read the number, then for I is equal to 2, I less than number, I plus plus. Okay, then if number is having any factors, number mod I double is equal to 0, then say flag equal to, then say flag equal to 1. Okay, so that's it. Then after coming out the loop, just say if flag still 0, that means what? Printf given number is prime number. Okay, else printf given number is not prime number. That's it. This is the first way. Okay, so this is the first way. Okay, or method 1. Okay, then add the get ch and close this. Okay, now if you look at here, let's take some example. Why we are starting, this is I, sorry. So why we are starting with 2? That's what I already told you. Prime number starts with 2. Okay, and if you see the definition, what is a prime number? Number greater than 1 and has only one divider. That's why we are starting with 2. So greater than 1, that's why we are starting with 2. And why we are ending with less than n? Why there is no less than or equal to? Because we don't need to count the self factor. That's why we are ending with a less than number, I plus plus. Now we are checking if the number, given number, is divisible in between 1 and before the, or sorry, 2 and before the number, then I'm going to say it's a not prime number, else it is a prime number. This logic is available in all the textbooks, so it's a common one. Okay, now let's see, let's understand more on this. Let's say case 1. Let's say you are executing this program, enter number is 8. If enter number is 8, then number is equal to 8. Fine. So if enter number is 8, then how many times this loop will be executed? Okay, so how many times loop will be executed? That's the question. So if you look at here, so this is going to be 8. So with 2 it will one time, 3, 4, 5, 6, 7. So when it is a 8, then it comes out of the loop. So therefore, so it's 6 times. Answer is 6 times. So that means n minus 2 times. N minus 2 times. Okay. So assume one loop execution takes 1 minute. Then how much time this will take? So in this program, how much time it will take? Then total time taken is equal to 6 minutes. Only for loop execution. Then total time to execution loop execution is 6 times. Okay. Now let's see how to write a better program. So as of now, if I am considering loop execution is 1 time, then to find out prime number or not, when enter number is 8, then it is taking 6 minutes. Now can I write a better program which will give better results, or which will reduce the number of iterations, or which will reduce the loop executions? Yes, you can. So before that, let's see one more question. So the question is, if you look at here we are using a flag variable. So every variable will take memory. So if you see here, it's an integer. Integer will take 2 bytes or 4 bytes, depends upon the operating system. So now the question is, can we write above program without flag variable? Without flag variable, answer is yes. So let's see method 2. Okay, answer is equal to method 2. Second way. So I'm just taking entire program again. I don't want to type all the thing. Okay, so I'm not taking the flag variable now. I don't want to take the flag variable. So if this one, then I will say here itself printf not prime number. Okay, given number is not prime number. So that means if any factor is there, I am saying not prime number. Okay. Now if flag is equal to n, n means here no number, no, then I'm going to say it's a prime number. Given number is prime number. What does that mean? Let's say 8 is entered, so it will come here 8 by 2 0, so not a prime number. Let's say 5 is entered, so it will come here 5 by 2 no, 5 by 3 no, 5 by 4 no, 5 by 5, so false. It will come here, so this is 5, it's not flag I. Sorry, it's not flag, it's I. I is equal to number, so I become 5, 5 is equal to 5, yes, so I'm saying prime number. That's correct. Okay, so the next question is, if you look at here, so in this program to execute this, it is taking 6 minutes. Can we write better program? Can we write first program in better way? Answer yes. So let's see the method 3. So let me copy the same program again. Okay, so now if you look at here, let's take the number 10, or let's take the number 12. How many factors are there? How many factors? So if you see here, it is 2 is the factor, 3 is the factor, 4 is the factor, and 6 is the factor. These are the factors. I'm not considering 1 and self. If you are not considering the 1 and self, so what are the factors? 2, 3, 4 and 6. So these are all the divisible factors for 12. Fine. Now coming to here. So let's say assume that entered number is 12. What it is doing here? I is equal to 2. 12 by 2, 0. So it will come here. Flag is equal to 1. So if you look at here, if there is any factor, do I need to check for the next factor? No. If I find any factor, do I need to check for the next factor? No need. Okay, if I find that okay, it is divisible by 2, then there is no point of checking for next number. There is no point of checking for next number. Hence, I can just use the break here. I can use the break here. So now what happens? If you look at here, if given number is 8, so how much time it is taking? 6 minutes. Now let's see the same situation here. Okay, assume give enter number is equal to 8. So that means what? Number is equal to 8. If number is equal to 8, then what happens? So here it is 2. Okay, 2 less than 8, true. 8 by 2, 0. So it will come here, flag. Then there is a break statement. So it comes out of the loop. After coming out of the loop, what is the flag? 1. 1 is equal to 0, false. So it will print not prime number. So therefore, how many times loop is executed? Only one time is executed. So one loop execution, we assumed that 1 minute. So how much time it will take? Only one minute. So how many times loop will be executed? Loop will be executed only one time. Hence, total time for loop execution is equal to 1 minute. So this is how we can write the better program. Assume that enter number is equal to 11. Enter number is equal to 11. So if enter number is equal to 11, then how many times loop will be executed? It is same. So executed, executted, executed. It's like a n minus or 9 times. So n minus 2. So there is no difference in this scenario. There is no difference in this scenario. Now, can we write a better program? Now again, can we write above? That means above means third method. Okay, third method or first program, whatever it may be. Above means first program. In better way? Answer is yes. So now let's see method 4. Okay, so what is happening here? If you look at here, so if I am entering 8, then I am able to save some time. But if someone enters 11, then there is no difference between this program and the first program. There is no difference between this program and first program. So can we save something? Yes. So how do we save? So that's the next question. Okay. Now let's see. Now before we understand this method, okay, let's understand some theory. Okay. Okay. So the theory is something like this. Let's take the 12. So what are the factors? Let's take the number is equal to number 12. Then factors are what? 2, 3, 4, 6. Okay, let's take 20. Number 20. What are the factors? Factors, okay. 2, it is divisible by 4, it is divisible by 5, this is divisible by 10. Okay, so let's take the number, okay, maybe 27. So what are the factors? No factors. Okay, or let's take 25. What are the factors? Factors are 5, Only 5. That's it. So if you observe here, any number, if you take any number, that number will have factors up to number by 2. So what is the maximum factor? 6. 6 is nothing but number by 2. What is the maximum factor? 10. So 10 is nothing but 20 by 2. So what is the maximum factor here? 5. Definitely it is less than 25 by 2. That means what? Any number will have, this is the conclusion, any number will have factors, any number will have factors up to number less than or equal to, factors up to less than or equal to number by 2. That's the point. So if you look at here, this is having the factors, yeah, number by 2 means 6. All these factors are less than or equal to 6. All the factors are less than or equal to 10. All the factors are less than or equal to 25 by 2 means 12. All the factors are less than or equal to 12. That's correct. So I'm going to use this logic now. Okay, I'm going to use this logic now. So let me copy this one. Maybe I can take this one. Let me take this one. Okay. First program, maybe you can have it as third program because third program is a good one. So on top of that we are doing the changes. So this is the program. So number is equal to this one. So instead of number by 2, I can go with the number by 2. Instead of number, I can go with the number by 2. But here I should be, what is the logic? Any number will have factors up to less than or equal to number by 2. So therefore put less than or equal to number by 2. Put less than or equal to number by 2. That's it. So then number mod I is equal to 0, then break, blah blah blah. All these things are same. Now consider the scenarios. Okay. Assume enter number 8. So let's see whether it is okay. Assume number 8. If number 8, then obviously it is going to execute only one time. So how many times loop will be executed? Only one time. We already seen. Okay. Next is assume enter number is 11. So here it's taking 9 minutes, right? Total time. Hence total time for loop execution is equal to 9 minutes. This is just our assumption. Okay, we are assuming that one loop execution is 1 minute. For our understanding purpose, we have assumed. Okay, so now let's see. We are entering 11. So how many times loop will be executed? Now let's see. Okay, so this is 11 by 2. 11 by 2 means what? 5. So with 2 this will be executed. With 3 it will be executed. 4 and 5. So that means what? How many times loop will be executed? 4 times. So 4 is nothing but what? Number by 2 minus 1. That's it. Number by 2 minus 1. That's the logic. So therefore, how much time it will take? 4 minutes. So instead of it takes 9 minutes, now here it is taking only 4 minutes. Hence we are able to save the program, or hence we are able to save the time. This is how we need to write the better programming. Please remember, as I said in the previous session also, C language is there in the 4th class and it's there in the engineering. So you should show the difference than the others. How do you show the difference than the others? By doing different ways. Okay, by writing better programs, performance programs, all these things. Okay, that's about. So number by 2 minus 1. So this is the execution time. So hence it is able to execute only 4 minutes. So instead of 9 minutes, now it is taking only 4 minutes. Again, so now let's see, can we write again better program? Can we write better program? Next question, can we write some other way? Some other way? Answer is yes. Now let's understand one more way. Okay, let's understand one more way. So what is the one more way? This is method 5, this is method 4, and this is method 5. Okay, so the logic here is, okay, now coming to here again. Any number if you take, that will have factors less than or equal to square root of the number. Okay. Okay, let me put that conclusion. So here it is what? Here the conclusion is what? Any number will have factors up to less than or equal to number by 2. The other one is any number will have factors, this is another conclusion, factors up to less than or equal to square root of SQRT, square root of number. That means what? Let's take one example. Let's say number is, okay, number is, let's say 36. So what are the factors first? Factors are 2, 3, 6, 9, 12, 12, okay, so this not this conclusion. Okay, I'll tell you what is this meaning. Sorry, we are just going in a different way. Let me tell you this way. Okay, so the other way is something like this. So let me copy this program again. Okay, so the fifth way, so instead of you use this number by 2, you can use one more logic. So instead of this number by 2, you can use square root of number, and again you need to convert to integer, because reason is sometimes it may return, square root function will return double, so you need to convert into integer, sqrt of n, square root of n. So for I is equal to 0, I less than or equal to integer of, you are converting into integer, square root of n, then I plus plus, then do the same logic. And remember that this square root function is available in math header file, so you need to include it, hash include. I mean, these things you can take care, hash include math.h, and if you required you can include std.ioh, con.io.h, all these things. Okay, those are the things you can take care very well, no issues. Okay, now look at here, what is happening here. Let's consider this scenario. So here how much time it is taking? 11 minutes. So assume that enter number is 11. So that means number is equal to what here? 11. So what is the logic here? Square root of the number. Square root of 11, how much? SQRT of 11. So SQRT of 11 is something 3 point something. So what I did here, so if you see the logic, this is the logic I am applying. Okay, this is the logic I am applying. So this is going to be 11. So 11 means, square root of 11 means that is equal to integer of 3 point something, 3 point xxx. So I am converting into integer, so this result is going to be 3. This result is going to be 3. Now it will come here. So that means this entire thing is 3. Now it will come here. This is number, not n. So if any place no is there, please convert into if you see n, just make it as a number. Okay, nothing more than that. Okay, fine. Okay, now coming to here, this entire result is going to be 3. So it will check with 2. So 2, 11 by 2, no, it's not 0. So it will come here. Next 11 by 3, it is not 0. So next it will go here. 4 less than or equal to 3, false. So it will come out of the loop. So how many times the loop is executed? Only 2 times. How many times loop is executed? Only 2 times. So in case of 11, how many times loop is executed? Only 2 times. That means how much time it is taken? So only 2 minutes. How many times? How much time it is going to take? Only 2 minutes. That's the power of the programming. That's the power of the programming. So can we write in a different way? Yes. So let's see the other way. So maybe this is a method 6. Okay. So I'm just taking the, so instead of square root function, as I said, square root is a function available in math.h. So I don't want to use the square root function. Can I write in a different way? Yes, you can write in a different way. So this is maybe how to write above program without sqrt function. How to write above program without sqrt function. Okay, so this is a method 6. So now again I just pasted all the program. So enter the number is entered. Okay, now coming to here, you can start with 2, and so instead of here you can have I into I and less than number less than n. Number less than n, then I plus plus. If number mod is equal to 0, then do break and also on so on. So now let's consider the same scenario and see, okay, how many times loop will be executed. So this is a different way again. Okay, coming to here, assume that enter number is 11. Okay, now enter number is 11. So how many times loop is executed? It is going to start with 2. 2 into 2, 4. 4 less than 11. 4 less than 11, yes, it will come here. Then 3. 3 into 3, 9. 9 less than 11, yes, it will come here. Next to 4. 4 into 4, 16. 16 less than 11, no. So it will fail and it will come out. So how many times loop will be executed? Loop will be executed only 2 times. Hence, total time taken is 2 minutes. Hence, total time taken is 2 minutes. Okay, so that's the 6th way. Next, 7th way. Okay, if you look at here, if someone enters negative number, what happens? It's not going to work, right? If anyone enters the number less than or equal to 1, then this program is going to mess up something. Okay, so you need to write that program in a better way. So the question is, if someone enters number less than or equal to 1, then above program won't work. So you need to write a better way. You need to write in a better way. So how do I write in a better way? Take the same program. So this is the 7th method 7. So before you execute the loop, okay, before you execute the loop, just check if number less than or equal to 1. If number less than or equal to 1, if that is the case, then display a message printf, please enter number greater than or equal to 1. Greater than or equal to 1. This is a message. Else only you do this one. For loop, all these things. Else you can do this one for loop. Okay, you can start with this one and end here. One more bracket, okay? Else you are doing this. So whenever you write the program, please make sure you have proper spacings so that it will be easy for you to identify where the errors are coming. That's it. This is the 7th way. Now, can we write in a better way? Yes, absolutely. You can write in a better way also. So, but the next program may not work for all the numbers, but it will try to work for some numbers. Okay. So let me show you. So next is method 8. So I'm just taking this program. Let me not take this program. Maybe I can take this program. Method 8. Let me take this program and enter the number. Once I enter the number, then you can just write the if statement directly. If number mod 2 is equal to 0, or number mod 3 is equal to 0, or number, okay, or number mod 5 is equal to 0, or number mod 7 is equal to 0, or you can, I'm just writing prime numbers here, nothing more than that. Number mod 11 is equal to 0, and so on. So then you can write if this is the situation, then say prime number, else it is not prime number. That's it. Else it is not prime number. So here there are no loops. It's just a simple if condition. So if you look at here, I'm just trying to check with the prime numbers. But this is not suggestible solution because we don't know what is the next prime number. Okay, but if you know that, okay, yeah, you want to do this program quickly, then you can just use this logic. Okay, so here there are no loops, so only one time execution. It will come here and execute it, so it hardly do in 1 minute. Okay, next method 9. This is the best one. Method 9, this is the best one. Okay, so before we have this one, you can try, I know another 2 methods. You can try some more methods. As of me, if you ask me, I can write this one in another 2 ways. So method 9 and 10. You can also try to look at that and see the possibilities, and you can get back to me if you don't find any. But I am going to tell the method 11. Method 11. This is the best one. This is the best logic. So why I am saying this is the best logic? This solution is 3 times faster than other solutions. Other solutions means square root number solution or number by 2 solution, whatever it may be. So it's the best logic. Is the 3 times faster than other solutions, like say SQRT, number solution, or dash dash dash. It is 3 times faster than or more than 3 times also. Okay, if you consider with the first program, then it is more than 3 times faster. If you consider the second program, then it is more than 3 times faster. This solution is greater than or equal to 3 times faster. Okay, greater than or equal to 3 times faster than the other solutions. Okay, now let's see this solution. Let me take the same program. Okay, let me take the program. So you need to write carefully. So take the number, okay, flag CLR SCR, enter the number. Then once you enter the number, if number is equal to 2, it's a prime number, or number is equal to 3, then these are what are prime numbers. So printf given number is prime number. Else, please see, you need to write else all these things very carefully. Okay, else only you are writing if. Okay, if number mod 2 is equal to 0, or number mod 3 is equal to 0, then printf given number is not prime number, else. Okay, if it is else only, then I am going for the loop. Okay, and one more important bit here is, sorry, I'm just deviating to here, so I just want to cover that bit also. The fourth bit is all prime numbers except two are odd numbers. If you see all prime numbers, these are the prime numbers, right? These are odd numbers. There is no even prime number. Only even prime number is 2. So except 2, remaining all prime numbers are odd numbers. Okay, so that's the logic I am going to use it here. So if you look at here, I'm just checking number 2, 3, then I'm just printing prime number. If you look at here, most of the times here itself you will find, okay, so if number by 2 is equal to 0 or number 5 number by 3 is equal to 0, I'm saying here itself not prime number. I'm not going inside. Okay, I'm not going inside. So if 90% of the cases, or at least 70% of the cases, here itself it will stop. So it will not go to the inside the loop. Okay, let's see. Let me finish this program. This brackets, everything is important, otherwise this program will not be executed. Okay, so this is ending here. So if okay, let me hit this one. If number is equal to 2, 3, then prime number, else number by 2, number mod 2, number mod 3, then you are saying not prime number, else then it will come to inside the loop. Then directly you can start with 5 because 2, 3 are already covered here. Directly you can start with 5. So you can start with 5, and I into I, yes, you can use it. I into I, you can use it, less than or equal to number. Next, no need to do I plus plus. So you can directly jump 6. I plus is equal to 6. I plus is equal to 6. Okay. Next, coming to here, if number mod I is equal to 0, or you need to write one more logic. Okay, or if number mod I plus 2 is equal to 0, then flag is equal to 1, break. Okay, then flag is equal to 1, break. Now if you come here, if flag is equal to 1, that means it is coming inside. If flag is equal to 1, or if flag is equal to 0, let's go with the flag is equal to 0 only. 0 means what? It did not go inside the loop. Hence given number is prime number. If flag is equal to 1, that means it went inside the loop or inside the if. So therefore 1 is equal to 0, false. So it will come here and print the not prime number. Then it will come out of the loop. Then it's done. So this is how you can write the prime number program in different ways. Okay, thank you for your time. If you have any questions, you can get back to me. Please improve your programming skills. This is how you can show to the top companies that you are unique. If you are just doing like others, then maybe you are equal to 7th class guy or 6th class guy. If you want to say you are a BTech guy and do the program better way and increase the performance, then try in a different ways. Thank you very much. Bye.